Hi everybody, got a short video to refresh your memory as to what SOHCAHTOA is, what trig functions are, what inverse trig is, and how all this comes together to relate sides and angles of right triangles. So we had this acronym, SOHCAHTOA, all right? And we know that we can apply this to right triangles. So if you've got a triangle with a right angle, we can relate one of the acute angles in the triangle to the three side lengths, all right? And we do that through SOHCAHTOA, where sine is S, C is cosine, and T is tangent. And so SOHCAHTOA helps us to remember what are the ratios of the side lengths that go with each of those trig functions. So for example, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And that means that relative to some angle, an acute angle in the right triangle, and in this case I've designated that angle to be theta, relative to this angle, x, this is our opposite side, that is across the triangle from theta, it is opposite. Y is adjacent, it is right next to, and z is the hypotenuse, all right? Now I know that both z and y technically are adjacent to theta, but the important thing to remember is that the hypotenuse, you don't have a choice of where to put that. The hypotenuse is across from 90, so that would be z, all right? So relative to angle theta, x is opposite, y is adjacent, z is hypotenuse. Using SOHCAHTOA, using that acronym then, the sine of angle theta, some angle in degrees here, that is acute, that's less than 90, would be the ratio of these two sides, x over z. Cosine of that angle theta would be y over z, the ratio of adjacent over hypotenuse. And tangent of theta would be the ratio x over y. It would be opposite over adjacent, okay? So those are our three basic trig functions. Now when we covered that, we also talked about inverse trig functions, and they relate to sine, cosine, and tangent in the following way. So what you might recall from inverse functions is that when we're trying to find the equation of an inverse function, we switch the x's and the y's, and it's basically the same thing with inverse trig. So your inverse trig functions, sine inverse, this is not sine to the negative 1, that's not an exponent. That is notation that represents sine inverse. So sine inverse of the trig ratio, opposite over hypotenuse, equals theta. Notice what's happened. The theta, the angle measure, and the ratio, x over z, they switch places, and that gives you inverse sine. Similarly, cosine inverse. What's happening with cosine of theta equals y over z? The theta and the ratio, they switch places, and now cosine inverse of that ratio equals theta. And finally, tangent, tangent inverse of x over y, the ratio, is equal to theta. So this is just a refresher on what we've already covered. It's coming back, and I have to introduce one new concept to you, and that is the concept of reciprocal trig functions. These are inverse trig functions. There are three reciprocal trig functions. All right, so I'm going to erase this, and that's an important difference. Inverse and reciprocal mean different things here. I'm going to keep up our three basic trig functions. So I'm going to keep up these here, sine, cosine, and tangent, and now we're going to talk about reciprocal trig functions. Reciprocal trig functions. Okay, there are three of them. The first one is called cosecant, all right? And we shorthand that CSC. CSC of an angle theta. Cosecant is the reciprocal of sine. Now think about what a reciprocal means, right? If you have a fraction and you're taking the reciprocal of it, you switch the numerator and denominator. That's exactly what we do with cosecant. Cosecant of theta is the reciprocal of sine. Therefore, cosecant of theta is equal to z over x, the reciprocal of the ratio that sine is equal to. There's another reciprocal function. It's called secant of theta. Secant is the reciprocal of cosine. Therefore, secant of theta in that triangle would be equal to z over y. And finally, the reciprocal of tangent is cotangent. COT, cotangent, and that would be y over x. They're just reciprocals. So if you think about what that means then, from our acronym, SOHCAHTOA, sine is opposite over hypotenuse, that means that cosecant is going to be x over z, which is opposite on the bottom, and on the top, your hypotenuse of z. So it's basically z over, h. It's h over o. H over o. Hypotenuse over opposite. That's where that comes from. And secant. So secant comes from cosine. If cosine is adjacent over hypotenuse, then secant is going to be hypotenuse over adjacent. So hypotenuse h over adjacent. That's that ratio. And lastly, cotangent, if it's the reciprocal of tangent, instead of opposite over adjacent, it's adjacent A over opposite O. And so if you can remember SOHCAHTOA, and you can remember which reciprocal goes with which trig function, then it's easy to figure out how to turn the trig ratios, how to turn them into reciprocals from SOHCAHTOA. All right. The other important thing here is that what you may notice on your graphing calculator, there are no buttons for cosecant, secant, or cotangent. There are buttons for sine, cosine, and tangent. There are buttons for sine inverse, cosine inverse, tangent inverse. Okay, so then the question is, well, how can I evaluate these on my calculator? Well, it's not so bad. These are reciprocal trig functions, right? So what that would mean is cosecant of some angle theta would be equal to 1 over sine of theta. And so in your calculator, if you're trying to come up with the cosecant of an angle, that's just 1 divided by the sine of that angle. We can keep this going. What about secant? If you're trying to come up with the secant of an angle, well, that's just going to be 1 over cosine of that angle. And you can evaluate that in your calculator. And then the very last one, cotangent, you guessed it, cotangent of an angle will be 1 over tangent of that angle in your calculator. So even though there aren't designated buttons for those things, there's a workaround so that you can actually evaluate them using your graphing calculator. And that's basically everything you need to know. That's your short introduction to trig. Short review. Happy distance learning.